Hello students, in this class I'll be teaching you the Bayes theorem and problems based on that. So to begin with the Bayes theorem, let us first recall what is a conditional probability. So let A and B be two events, then the probability of A under the condition that B has already occurred is called conditional probability and is denoted by probability of A given B. So it is defined and it is given by probability of A given B is equal to probability of A intersection B divided by probability of B. So from this we can write probability of A intersection B is equal to probability of A given B into probability of B, which is called as the multiplication rule. Now let us look at what is a Bayes theorem. Let A1, A2 up till A and B mutually disjoint events whose union is the sample space S with probability of AI not equal to 0 for each I. If for any arbitrary event A, which is a subset of union AI with probability of A greater than 0, then you have this formula. So it is given that S is a sample space. So I take S to be the sample space of the random experiment. And it is given that these events union is equal to S. So you have these events A1, A2, AN up AN which are mutually disjoint. Mutually disjoint means you take any two sets and take their intersection, that will be equal to empty. So S is equal to union of all these ANs, and it is also given that A is a subset of S. This is a notation for subset. So A is a subset of S. So therefore A is equal to, A can be written as S intersection A as A is a subset of S. So this is equal to S, you write down what is S. So A1 union A2 up till AN intersection A. Now you're using the distributive law and we can write this as A is equal to A1 plus A1 intersection A union and so on. Now applying probability on both the sides, we get this as probability of A is equal to probability of A1 intersection A plus probability of A2 intersection A and so on up till probability of AN intersection A. The reason is these events are disjoint. So whenever you have a disjoint set, then probability of A union B is equal to probability of A plus probability of B. The reason is A intersection B is empty and probability of empty set is equal to 0. So we don't go for the other part of intersection. So since they are disjoint, we can write it like this. So applying multiplication rule onto each term in RHS, that is the multiplication rule which I already told you. So probability of A is equal to probability of A1 intersection A can be written as probability of A1 into probability of A given A1 plus probability of A2 into probability of A given A2 and so on plus probability of AN into probability of A given AN. So this can be written in the summation notation as this form. So probability of A is equal to summation I is equal to 1 to N probability of AI into probability of A given AI. So conditional probability of AI for all I given A is given by, so we need to find out what is probability of AI given A. So probability of AI given A is equal to probability of AI intersection A divided by probability of A, or I can write this as, this one can be written using the multiplication rule as probability of AI into probability of A given AI divided by probability of A, and you consider this as a second statement. So using 1 in 2, we get the formula. So probability of AI given A is equal to probability of AI into probability of A given AI divided by summation I running from 1 to N probability of AI into probability of A given AI. So whenever you're solving problems based on Bayes theorem, you should always find out what are these AIs in using by reading the problem, and to find what is A, what should we have to find with respect to what condition. So let us go for the problems. First problem. In a bolt factory, there are 4 machines A, B, C, D manufacturing respectively 20%, 50%, 25%, 40% of the total production. Out of these, 5%, 4%, 3%, 2% are defective. If a bolt drawn at random was found defective, what is the probability that it was manufactured by A or D? So we have four events A1, A2, A3, A4 as A, B, C and D. That is bolt manufacturing from A, bolt manufacturing from B, C and D. Now we need to find out if a bolt drawn at random, if you draw a bolt at random, then you need to find what is the probability that it is found to be defective. So from by data we have probability of A is 20% because 20% bolt factory, there are four machines manufacturing respectively of the total production. Out of the total production, 20% is from A, 15% is from B, 25 is from C and 40 is from D. So probability of A is equal to 0.2. Probability of B is equal, since it is a percentage, we convert it into decimals. So 20% is 20 by 100, so we get it as 0.2. Probability of B is 0.15. Probability of C is 0.25 and probability of D is equal to 0.4. Now I take let E be the event of selection of a defective bolt. This is E. Now it is also given that if it is defective, if a bolt is defective, then from which machine is a defective bolt from, we can find the probability is already given. So out of these total production, you have these percentage to be defective from these machineries. So we have probability of E given A is equal to 0.05, that is 5%. Probability of E given B, that is the selection of a bolt being defective from the machine B, that is equal to 0.04. Probability of E given C is 0.03 and probability of E given D is 0.02. Now, since A and D are mutually exclusive. Mutually exclusive means these two events are happening differently. That is, when you take the intersection, that will be always equal to empty. That is what mutually exclusive means. Mutually exclusive is nothing but the disjoint events. Both are happening independently, A and D. So we have probability of A union D given E is equal to probability of A given E plus probability of D given E. The reason is A intersection D is equal to empty and probability of that is equal to 0. Probability of empty set will always be equal to 0. So we need to find probability of A given E. That is probability of that the bolt drawn from A given that it is defective. So to find from Bayes theorem, we have probability of A given E is equal to probability of A into probability of E given A divided by this. So substitute all the values because we have all these values and you simplify, you will get this answer. Similarly, we can do for probability of D given E as well, and therefore probability of A union D, because we need to find out what is the probability that it was manufactured by A or D. Whenever you have an OR condition, that means it is union. So we have probability of A union D given E is equal to probability of A given E 0.3175 plus probability of D given E, that is 0.254. You will get the final answer. Now let us look at the second problem. Almost all the problems are of the same type. You just have to find out what are these mutually disjoint events and what is that A which has to be found out from the condition given in the problem. So we have the second problem. A bag X contains 2 white and 3 red balls and a bag Y contains 4 white and 5 red balls. One ball is drawn at random from one of the bags and is found to be red. Find the probability that it was drawn from bag Y. So we have also two events here, that is bag X and bag Y. Balls containing, the ball is drawn from bag X and A2 is the ball is drawn from bag Y. If the condition is it is found to be red. So that is A is the set, A is the event, the ball is red. So we need to find the probability that it was drawn from bag Y. So bag Y is A2. So we need to find out probability of A2 under the condition that the ball is red. So probability of A2 given A. So from Bayes theorem, we have the formula. Since the two bags are equally likely to be selected, we can write probability of A1 is equal to probability of A2, that is equal to half. Now, probability of a red ball is drawn from bag X. What is the probability that a red ball is drawn from bag X? So, in the bag X, there are 2 white and 3 red. What is the probability of drawing one red ball? So, totally there are 5 balls, and drawing a red ball is given as 3 by 5. Similarly, a red ball is drawn from bag Y. There are 4 white and 5 red balls. So probability of drawing a red ball is 5 by 9. So now we need to find out what is probability of A2 given A. So we are drawing a ball from bag Y given that it is red. So substitute the values, you will get the answer. Next, third problem. Given 3 identical boxes 1, 2 and 3, each containing 2 coins. In box 1, both coins are gold. In box 2, both are silver coins. And in box 3, there is 1 gold and 1 silver. A person chooses a box at random and takes out a coin. If the coin is gold, what is the probability that the other coin in the box is also of gold? So you have 3 events, A1, A2, A3. That boxes 1, 2 and 3 are chosen respectively. Now the event A is that the coin drawn is gold. If the coin drawn is gold, what is the probability that the other coin in the box is also of gold? So let A be the event that the coin drawn is gold. So probability of A1 and probability of A2, probability of A3 is nothing but 1 by 3 because they are all equally likely events. Then we need to find out, okay, before that, okay, now what is the probability that the other coin in the box is also of gold? Then which box has to be selected? If the coin selected is gold, what is the probability that the other coin in the box is also of gold? Means we need to select the first box itself. So probability of selecting the first box, we need to find the answer for. So here, so we have to find probability of A1 given A. So probability of A1 given A. So to do that, we need to find out what is probability of A given A1. That is, a gold coin is drawn from bag 1. Since in bag 1 both are gold coins, the probability of getting a gold coin is 2 by 2, that is equal to 1. Probability of A given A2, that is the probability of a gold coin from bag 2 is equal to 0, as there are no gold coins, there are only silver coins. And probability of A given A3 is probability of gold coin from bag 3, that is equal to 1 by 2, as there is 1 gold and 1 silver. Now the probability that the other coin in the box is also of gold means the probability that gold coin is drawn from the box 1 only. So we are finding out probability of A1 given A. So once you draw a coin, the other coin you draw must also be of gold. So that means you need to select the first box itself. So probability of A1 given A, using the Bayes theorem, you have this definition. And all these values we already found out. So substitute and you will get the answer. Next problem. A man is known to speak truth 3 out of 4 times. He throws a die and reports that it is a 6. Find the probability that it is actually a 6. Now, there are 2 events, even and E2 I consider. So the events even and E2 are, even is that 6 occurs and E2 is 6 does not occur. So we need to check what is the probability that it is actually a 6 when a man told that it is a 6. So A is, the man reports that it is a 6. So man reports that it is a 6. We don't know whether it is true or not. He just reports that it is a 6. So we need to find out, we have, so we need to find out probability of probability of 6 occurs. So probability of even given A. So what is probability of even? Probability of even is, you throw a die here. So when you throw a die, 6 comes only once. So probability of even is equal to 1 by 6 and probability of E2 is equal to 5 by 6. Now probability of A given even, that is probability that the man speaks the truth. So the man is known to speak truth 3 out of 4 times. It is given already. So probability of A given even is equal to 3 by 4 because he has reported that it is a 6 and 6 actually occurs. That is what it means. The probability of A given even is probability that the man speaks the truth is equal to 3 by 4. Probability of A given E2, the probability that the man does not speak the truth is the negation of probability of A given even. So we have this as 1 minus 3 by 4, which is equal to 1 by 4. So from Bayes' theorem, we need to find out what is probability of even given A. That is, a man reports that it is a 6 and 6 actually appears. So probability of even given that the man has spoken the truth. So probability of even given A is equal to probability of even into probability of A given even, and using the definition and substituting these values, you will get the answer as 3 by 8. Some more problems can be done based on the Bayes theorem, and the same procedure follows. You need to first find out what are these disjoint events and what is that one event under which the problem is being solved. So looking into it, you can do some more problems based on Bayes theorem. Thank you.